Good evening. I am Dr. Matthew Koshi, the Honorary Director of CSI Senate, Department of Ecological Concerns. Dear Mr. Dinesh Shuna, Dr. Srija, teachers and participants, a warm welcome to all of you. Mr. Dinesh Shuna is inaugurating today's program. Mr. Dinesh Shuna is the coordinator of the Ecumenical Water Network of World Council of Churches, Geneva, since 2012. WCC is a global fellowship of 350 Protestant and Orthodox churches in 110 countries, representing over 500 million Christians. The Ecumenical Water Network, EWN, started in 2006, is a platform of Christian churches and organizations committed to increasing access to safe drinking water and dignified sanitation worldwide. EWN primarily engage in advocacy for water justice within a human rights framework. Mr. Shuna has a postgraduate degree on journalism and mass communication and a postgraduate mass communication and a master's degree in social work. Currently, he is also one of the co-leads of the Partnership of Religions and Sustainable Development work stream on environment, water, and climate action. Mr. Shuna, we cordially welcome you to this program. Dr. Srija KG will be taking class on ocean and climate change. Dr. Srija has a PhD in Agriculture Systems Management from National Institute of Advanced Studies, Bangalore, and a 3-year postdoctoral fellowship in Climate Change Impact Assessment at the Indian Institute of Technology, Mumbai, India. She is a scientist and actively working with ICNOT. Dr. Srija, I welcome you to this program. I welcome all the students, all the clergy, college teachers, and some other students attending this program. There are 2 announcements also. The participants can write their questions and clarifications in the chat box. Immediately after the vote of thanks, a link will appear in the chat box, and participants have to click on the link to get questions for today's quiz. You will be directed to Google Sheets. We will give you 7 minutes to answer. We will value it within the next 5 minutes, and the results will be announced immediately. In order to fill the gap between the vote of thanks and valuation, we will be posting a small video. First 3 will get cash awards. There will be 10 more prizes as encouragement prizes. First 3 winners have to give Google Pay account or the bank account before 6 p.m. tomorrow to the WhatsApp number 98472-75754. Others have to send their postal address. Now I request Mr. Dinesh Shuna to inaugurate the program.
Okay. Thank you very much, Professor Koshi. Professor Koshi is someone I hold him with very high regards because he's very much committed all along that I have known him on the ecological issues. And I jokingly used to tell him that if you are an honorary director of the Church of South India, and then you're setting a very high benchmark for the other directors who are probably full-time, and you're working more than full-time. And he just smiles as usual, but continues to do the work. So thank you very much, Professor Koshi, for doing this wonderful work. And I think what you have initiated this campaign on climate resilient churches, communities, and schools. And what a better way than to start when the minds are young and fresh, the students. So big congratulations on behalf of the World Council of Churches here in Geneva, but also from the worldwide. A particular thanks also to you on behalf of the Ecumenical Water Network of WCC, which I do coordinate. I think I would just like to, it's very timely that before we speaking, just a couple of days before, we have the IPCC, the United Nations Intergovernmental Panel on Climate Change, which is an authentic body which monitors and guides the world leaders and the scientists on climate change related issues. They released their report, and it's alarming to say the least. And I'm sure you will get an opportunity to hear more about this. But then, as we know that people around the world in many regions, they are suffering these days, including in India. We have massive floods in Western India, landslides, and several hundred people died. But also in less known areas, like here in Europe, in Germany, we have massive floods not seen in a century. And now in Southern Europe, in Greece and other parts of the world, we have extreme high heat wave above 43, 45 degrees centigrade, where forest fires are a common phenomena. Or you go to the United States of America, in California and other parts of the United States are suffering from massive wildfires and so on. At this poignant time, we have this report that was released. And this report has now once for all categorically labeled the cause or the onus on us human beings, because we have contributed so much to the climate change that no other species has been able to do. It's quite infamous, but unfortunately a sad reality of today. And therefore, the human-induced climate change has continuously contributed to the increase of the global temperature. The period in the history that we call the Anthropocene, that is the human-centered or the ruled Earth, this has impacted the human domination in the past 200 years of industrialization that cannot be compared with any point in the past in the history. And this is kind of cannot be reversed. So only option we have through the Paris Agreement, I'm sure you would get to know that, or you probably already know about it. It helps us, gives us a tool to curb it to the global temperature rise to ideally 1.5 degrees centigrade, or at least to 2 degrees centigrades. And I'm sure you know already that every year the world leaders, they meet in a mechanism provided by the United Nations Framework Convention on Climate Change, the UNFCCC, as we call it. We call the Conference of Parties, and all over the world, people will be joining in November this year in UK, in Glasgow, where they meet to discuss about the problems and challenges of climate change, as we call it the COP26. For the 26th year, COP will be meeting to discuss about the problems of climate change. We have already seen many climate activists, but particularly the young children have played a major role. The school students have started the campaign called the Fridays for Future. A young student like many of you, her name is Greta Thunberg from Sweden, who every Friday used to sit in front of the Swedish parliament. And today she is a celebrity. You can, I'm sure you know, otherwise just Google her later on. She and many others from India, from Africa, from Europe and North America, young children are now challenging the global leaders to take serious actions. And I'm sure the campaign that Church of South India has started with the leadership of Professor Koshi and others would go a long way in creating many Greta Thunberg from within the CSI, from within among you, who probably tomorrow would be challenging the Indian government to take adequate action, because we ourselves, our country also has a lot to catch up with. We cannot hide anymore with the large population that we have, and therefore we have a smaller carbon footprint. We also have to change to cleaner energy and cannot depend so much on the the dirty energy or the fuel, the coal-based energy sources. One thing I wanted to tell this to all of you, that the one scientist, and with that I will end, Professor Ed Hawkins from the University of Readings in UK, and one of the authors of the IPCC report that was just released 2 days ago, that scientists can no longer at this point argue that climate change has got nothing to do with human beings' contribution. So I have said this in the past earlier, and now also I would say that in the last 50 years alone, what we have contributed to climate change, in no other point in history, any other species has contributed. So therefore, it's time that we also have to mend our ways. Professor Siraj, Dr. Siraj would continue to talk on climate change and ocean, but as we all know that oceans are the largest carbon sink on the planet Earth. But as a result, oceans absorb so much of heat that they themselves, ocean itself is getting hotter and hotter, and thereby the acidification process is contributing to climate change. And it's a kind of a cycle, where vicious cycle, we cannot come out of it. More on this, I leave it to Dr. Siraj, but I want to thank Professor Koshi again for giving this opportunity to me to say something, but we wish you very well as you continue this until November, all the way, I think, up to COP26 probably. And I myself and many of my friends will be attending the COP26 in Glasgow, and I hope some of you, maybe Professor Koshi or any others, could also join us there. But we will be able to tell your stories, what you're doing as students. What a better way to change a community through students, through their parents and the larger community. My best wishes to you all, and particularly to Professor Koshi. Thank you very much.
Thank you, Suna, for your inspiring words. I call upon Dr. Srija for his keynote, for her keynote on this.
Good evening, distinguished chief guest, respected Dr. Matthew Koshi and other dignitaries who are attending the talk, and my dear children and dear teachers. I am audible, right?
Yes, yes.
Okay. So yeah, today's topic is on oceans and climate change. Like Mr. Suna was saying just now, the IPCC AR6, the 6th annual report of Intergovernmental Panel on Climate Change, was released just yesterday. And we have all been awaiting it with anxiously, because although we have got an idea of what is going on because of so many things that have been upon us during the past 2 months. July and August have been particularly vicious for the Western countries in Europe and America. There has been the heat dome, which had put Canada and the Western United States, several of the states under its hold, followed by floods in Germany. And even now wildfires are raging in Turkey and parts of Greece. Now now we live in a world which is strangely one whole global village, and at the same time totally fragmented. We all receive news which is important to us, which we kind of search. So our news feeds are tailored to our interests, our choices, so that it is a partial world that we are all familiar with. So even though the entire knowledge base of the internet is within our fingertips, we are not able to be aware of the entire things that are going on simultaneously. It's a very different kind of world, and therefore, even if there are things which are so much important to our existence, so much important to our survival, we can blissfully be unaware of it for a period of time without realizing the damage that is being done to our shared futures, to our shared resources, to the life-giving property of this unique planet. So it is one such aspect of this that I would like to share with you today, and that is on oceans. Now, because of a lot of rigorous efforts by people to take climate change onto public discussion platforms, for the past 1 year, there is a lot of talk on climate change, how it is affecting our lives, how it is affecting global biodiversity, how emissions are, creating a world that is getting increasingly difficult to live in. But the aspect of oceans again has not received so much of attention in popular discourses, narratives. So it is this aspect, therefore, which I think has to be given more, it has to come more in conversations, and let's try and begin here today. Um, so the talk will be simple enough. I'll talk about the oceans of the world and what does climate change and oceans have in common? I mean, what are the aspects that we should be aware of? The changes that are happening as a result of climate change, this impact on the oceans, and these impacts are put in a more socioeconomic context. Now, I would end the talk there. I will not be going into solutions because we should, it is time that we realize that, that climate change is an emergency. It does not, you cannot tackle it with small, solutions like, it's not that simple. So once you reach the impact part of the presentation, I hope to build the subject to you so that, the one becomes aware of the massiveness of the issue. And yes, so let's start with the oceans of the world. Now, several of these you must be aware of, but then let's begin at the start of the story. Now, oceans, as we all know, constitute around 70% of our planet. We live in the 30% of the land, and most of the times we forget that our planet is mostly water. And not just water, 97% of the water on our planet are found in the oceans. We learn it the other way around in schools. We learn that 3% of the drinkable water is found on the land, whereas the other 97% is found in the oceans. And it constitutes 70% of our the share of our planet. And actually it's just one ocean. Okay, the world ocean is just one ocean. It is interconnected, therefore it is all one big body of water with the continents floating in between. But because of several differences in physiochemical properties, socio-cultural histories, and how several oceans have been traversed by several people historically, who have been living in the rims of these oceans, the laws that govern these ocean bodies, we have divided these oceans into 5 major oceans. And one, the greatest of it, almost 30% of which is the Pacific Ocean. And the Pacific Ocean lies between the continents of America, South and North, and that of Australia and Asia. It is the biggest ocean, the Pacific Ocean. And you have the Atlantic Ocean, which lies between the Americas and Africa. Then you have the Indian Ocean, which is one of the smallest oceans, our own ocean. And in the poles, you have the Arctic Ocean. And quite recently, the Southern Ocean has also been kind of agreed upon by almost all international bodies to be a separate ocean. Otherwise, the ocean that surrounds Antarctica that you see here was supposed to be an extension of the Indian Ocean. But very recently, many of the international bodies have agreed to call it a different ocean by the name of Southern Ocean. So you have all these neat divisions of the world ocean into 5. And so these are the major takeaway points that I've been telling you. There is only one global ocean, which constitute around 70% of the planet's surface and holding around 97% of the water on the earth. Now, another very important point is that 50 to 80% of the oxygen that we breathe is produced by oceans. Now, this was news to me when I read it, because we have been reading up of our dense rainforests, the cover of tree cover on our land, which produce our life-giving oxygen, but that is minuscule compared to the oxygen production of ocean. Now, what produces oxygen in the ocean? These are the phytoplanktons, which are present on the ocean surface, and these form the base of the marine food webs. It is the phytoplanktons which then feed the zooplanktons. The zooplanktons then get eaten up by small fishes and krills. Small fishes and krills then get eaten up by larger fishes and penguins. And these then get eaten up by the larger fishes, more larger fishes, and other seals and whales. So this is the kind of marine food web which starts with the phytoplanktons, and that is where the 80% of the oxygen that we breathe in also gets produced. Now, as I said, the boundaries evolved over years, and 4 named ocean, and the 5th one as the Southern Ocean. And the largest ocean is Pacific, and jurisdictional boundaries of maritime countries is 200 nautical miles. Now, this is one information I thought, you would like to know. Now, who governs the world's oceans? We know that countries are governed by the nation states. We have the United Nations, which then bring together all the nations of the world. But then who governs the oceans? Who has right over the oceans? Now, there is a United Nations Conventions on the Law of the Sea. It is called UNCLS. This was arrived at with after a lot of disputes and conflicts between the maritime nations, and after 20, 25, 30 years of constant going back and forth by these nations, in 1996, I believe, it was firmed up, the United Nations Convention on the Law of the Sea, by which the jurisdictional boundary of a maritime country is 200 nautical miles off the coastline. That is, up to 200 nautical miles, a country can exploit the resources that are there in the sea. And there are several other distinctions also. I'll come to it. So here you have the 2D version of the oceans. Here you have the Southern Ocean, and the Atlantic Ocean has been divided into North Atlantic Ocean and South Atlantic Ocean, divided by the equator. The same goes for Pacific into North Pacific Ocean and the South Pacific Ocean. Indian Ocean is smaller, so you have the larger Indian Ocean, and normally we don't call it South and North, because mostly it is here in the northern portion with the Arabian Sea and the Bay of Bengal that we are so familiar with. And here, this side again is the Pacific Ocean. This is the basic geography map that you get to study in schools, but rarely do we look at the oceans. It is always the continental masses that we give our attention to, where the countries are located, where the capitals are located, what are they called. But right now, zoom your attention to the ocean part of it. And here the Southern Ocean, it is divided by the 60-degree south latitude. That is the line that divides Southern Ocean from the Atlantic and the Indian Ocean. So this is your most basic ocean map. Now, what do we have here? Now, this is a map of the life of the sea. Now, this map is just a very bland map, which does not give you much information on what an ocean is, But here, when you look at this, you can see the edges of the waters lighted up in light blue color. Now, what does that signify? This is a satellite image. It is real image of how the ocean looked. Of course, it has been worked with a bit so that, these contrasts are clearer to you. Now, these lighter green portions that you see around the edges of continents are where there are maximum life in the ocean. That is where you can find concentrations of phytoplanktons. Phytoplanktons are diatoms and other algal growth, which give life to the ocean. As I explained to you before, that forms the foundation of a marine food web. And you can see that it is nearer to the coastal regions that the richest waters of the oceans can be found. And look at where India is. See here, in this region, you can find that this entire coast and the this particular bay region is really rich in marine food webs. So this is the life of the ocean. And here what you see. Now, this map showed you the biology of an ocean, the life of an ocean. Now, this shows you the movements in an ocean. An ocean is never still, because there are constant movements in the ocean, which is actually responsible for the life on Earth that we are so familiar with. Now, these, Van Gogh-like lines that you see on the surface of the ocean is actually ocean currents. Now, water in an ocean keep moving in patterns which are dictated by the temperature of the water. So normally, hot water which carries heat from the equatorial regions are getting transported to the polar regions in south and the North Pole, so that uh, aided by the rotation or the spin of the earth, the waters are in a continuous motion. And during that motion, the heat, salt, acidity, and several of the physiochemical properties of the ocean waters get distributed in its entire surface and depth. So this body of water that I'm speaking of is in continuous motion, and it is this motion, these properties of the ocean waters that get affected with climate change. So this is what we are looking at, and this particular particular current that I'm tracing right now is the Gulf Stream. It starts at the Gulf of Mexico in the equator, and then it takes the heat from the equatorial regions and it goes towards the Western European nations. And it is an interesting story of its discovery, because people used to use this current to traverse in ships in the 15th 16th centuries, and they were aware of the current but really not aware of the properties and its extent. So once it happened that this person was in charge of the postal department in Britain, and he had a complaint coming in that letters which are posted from Europe takes a lot longer to reach Britain than it takes from Britain to reach its colonies. So what is happening was the question, and it was then realized that ships that are going out from the colonies in the Americas to Britain actually followed the path of the current, and therefore they could sail more with more speed compared to the vessels that are coming from the European states like London to their colonies. So that is going against the current, and therefore the current uh, slow down the movement of the vessels. So that with that started an inquiry which resulted in the mapping of the Gulf Stream and the temperature differences in it. And just to give you another perspective to it, very recently a study was published in the Nature journal, which found that the Atlantic meridional ocean currents, of which the Gulf Stream is a part of, is actually weakening due to climate change impacts. So that would mean that this current is slowly losing its temperature differences with that of its surrounding waters, and the current is weakening. Now, what does that mean? What does that mean for, does that mean that ships will now, be taking more time to reach these places. No, that was a different story. That was a different world. Now, the scientists, meanwhile, have discovered that these transport of heat and other chemical properties of the ocean waters through these currents actually decide the climate of the entire planet. It is the differences, pressure differences, temperature differences that are created by these flowing waters that then decide the intensity of the wind that gets blown to decide the intensity of our Indian summer monsoons. Of one of which it is the Indian summer monsoon. Monsoons all over the planet. There are several monsoons, of which the Indian monsoon is only one. And the patterns of monsoon, the intensity of monsoon, how much of rain we get, at what time do we get it, all these are decided by the intensity of the ocean currents. One of the factors is the ocean current. So once the ocean current's weakness, it has got wide-ranging impacts, one of which it is on the monsoon systems that we have all taken so much for granted. So that is jumping the gun. The story is yet to come. So just to give you an idea that, you are looking at an ocean which is constantly in motion, which is constantly turbulent. Another example that you'll be able to easily relate to is in the movie, what is it called? Finding Nemo. In Finding Nemo, the first part, you may remember that, Nemo's father, while going in search of his son, falls into the East Australian ocean current. That is how he reaches Sydney fast. And there is a turtle pathway that he takes, and that is the East Australian ocean current. So there are several ocean currents. 4 or 5 of them are very important. One of which is the Gulf Stream. Another is the East Australian ocean current. So ocean currents are I wish I could show you a video which shows ocean currents. If there is time, I will give you that, or I'll share with you the link, the NASA link, in which you can go and you can see these ocean currents in motion. Okay. Yeah. So this is to just give you the ocean in which we are, sitting in the brim of. We the Indians, especially the coastal inhabitants, are actually sitting in the rim of the Indian Ocean. We are an Indian Ocean rim country. There are 22 such Indian Ocean rim nations, maritime nations, who have a culture of their own. We have been trading with the Middle Eastern countries, with Africa, with the Southeast Asian countries for centuries. We have the rim countries of Indian Ocean have a culture of their own, or a culture of shipbuilding, a culture of fishing in its deep waters, a culture of shared recipes of fish dishes and means of fishing, the skill that is involved in coastal travel using the currents and the winds. So we are that way a special people. We have a history that has been shaped by an ocean. Though that part of our life is never too much dwelled upon. That again is another story. Let's dwell on it later. So just to give you an idea that we sit on the Indian Ocean. There is the Arabian Sea, the Lakshadweep Sea, and the Bay of Bengal. Lakshadweep Sea is actually part of the Arabian Sea. And this 51, 57 are numbers of the Food and Agricultural Organization of the United Nations, by which they have numbered the fishing grounds of the ocean. So this is major fishing areas that have been numbered by the FAO, and our Indian Ocean is FAO major fishing area 51 and 57. Just because these numbers are here, and you may be wondering what this signifies. Yeah, this is to just give you an idea of the political nature of the divisions of the sea. I told you that the seas are governed by the United Nations Convention on Maritime rules, and I told you this 200 nautical miles into the open sea is where a particular country can say ownership of the ocean resources. Now, before that, there is something called an internal waters, and up to 12 nautical miles, which is the territorial sea. An internal water will be a bay, like a Bay of Bengal, and water which gets into the land. So that will be an internal water. Then after that, up to 12 nautical miles, you have territorial sea. A territorial sea is where the nation has got control over the airspace also. So when you talk about the sea, the air above the sea is also important. Okay, so you have a national airspace and territorial sea up to 12 nautical miles from the land. After that, there is a contiguous zone, and in that contiguous zone of 12 nautical miles, you don't have ownership of the airspace. You can't have your air travel, especially the defense vehicles going in this airspace, after which you have the exclusive economic zone. And after this, you have the high seas. So this is how the sea is politically divided. And in this 200 nautical mile portion, after the 12 plus 12, 24 nautical miles, foreign vessels can come. And these are all important when it comes to wars and entry of warships into a nation's territory. So just to give you an idea, that how these, and a continental shelf is where there is most of your fishing resources located. In the high seas, it's again a different ecosystem with the different types of fishes and marine species involved. Yeah. So now with this background on the world's oceans, we pass on to climate change and the oceans. How does climate change impact the oceans? Now, we are all very aware, and if at all there has been some doubt in the most hard-boiled of cynics whether climate change is in fact the doing of the human race in the Anthropocene, with the IPCC sixth assessment report, they have laid down with certainty, 90% certainty. Now that kind of certainty was not there for the previous reports. During the assessment report 5 and 4, these the ascribing of the reasons for climate change was not 90%. It was likely, more likely, highly confident. These were the scales of certainty that we have traversed over the years to reach a point where with 90% certainty, the scientists are saying that climate change is anthropogenic. Whatever changes that you're seeing in the Earth's atmosphere is caused by the actions of the humans on the Earth. Now be very clear on that, children. There is no doubt, no ambiguity anymore. So there has been a release of greenhouse gases into the atmosphere. These greenhouse gases, mainly carbon dioxide, has been trapping heat from the sun, due to which the air has been heating up over the years, especially post-industrial years, that is after the discovery of this much of oil and the use of oil in transportation and industrial processes. The release of so much of greenhouse gases, methane and carbon dioxide, the main of them, into the atmosphere. And once the build-up carbon dioxide and the greenhouse gases is measured in ppms, parts per million. So the parts per million of carbon dioxide equivalent in the atmosphere has now built up to a level of 419 parts per million. From somewhere below 200 in the past 100 years, within 100 years period, we have built it up to 419. The last I have checked, it was 419 parts per million. And with this sizable increase in the proportion of carbon dioxide in the atmosphere has been heating up. That is what we have been calling global warming. And once the temperature has started building up in the atmosphere, according to this latest report, the temperature during the past 20 years, 2006 to 2020, has increased to the tune of 1.09 degrees Celsius. We have crossed the 1 degree Celsius limit. And of this 1.09 degrees Celsius, you have to divide that into land heating up and the ocean heating up. Be very clear that land has been heating up at a rate of 1.59 degrees Celsius. and ocean at a rate of 0.88 degrees Celsius. You average it together, you get this 1.09. So that is the world as we know it is 1 degree Celsius more warmer than it used to be 100 years back. Now that may not seem to you like much, what does 1 degree Celsius increase signify? 1 degree Celsius increase signifies a lot of things, my dear children. It signifies that, this heat that is building up is actually creating imbalances on the Earth's surface. And one of those imbalances is what I've just shown you back, what is happening to the ocean currents. The rest of it, we will, look at it now. But before the start of this very disturbing journey as to what is happening to our oceans, the first thing that you should remember is that only 7% of the heat being trapped by the greenhouse gases is sticking around in the surface of the atmosphere of the planet. It is this 7% of the heat that you are, witnessing as an increase in temperature that you feel, and also an increase in the extreme climate events such as heat waves and rainfall and wildfires. What happens to the other 93%? This 93% is being taken up by oceans. The oceans are acting as sinks of this extra heat that is getting built up in the atmosphere. So this, the 70% of the planet that is being covered in ocean is also doing this job of, taking in the ocean, taking in the heat that we are building up in the atmosphere. Now that may sound like a good thing for you, okay, so at least, that is happening. The oceans are acting as sinks. Whatever extra heat is getting generated, most of it is getting absorbed by the ocean. So well and good. Is that so? Let's look at what is happening to the oceans as a result of it. Now, ocean, as I told you, is not just one body of water. We have, the extent of it, we have divided into 5 oceans and named it. Okay. Now, let's look at the depth of it. Now, how deep is the ocean waters? Now, the ocean waters is not just one big column of water. Its properties, its chemical properties, its physiological properties all differ with vertically with depth. 0 to 700 meters is called as the upper ocean, whereas below 700 meters up to 2000 meters is a deeper ocean. And below that, again, you have, chasms, deep oceans, where the properties again are totally different. Now, the upper ocean has been warming at a higher rate because, of course, it is nearer to the surface of the Earth. It can absorb the heat more rigorously, and therefore these red lines that you see are the upper ocean temperatures at 0 to 700 meters. It has been sequestering more heat. Below you have from 700 to 2000 meters, which is again cooler waters, but again it is heating up. And then you have the deep ocean. So annual ocean heat content compared to 1993 average based on multiple data sets. Now these, why are there many lines here? Now there are many lines here because we are looking at different data sources. Now this is one thing that I would like to tell you, and just for you to grasp the amount of work that has gone into understanding the ocean processes. Now, when we are looking at climate change, its impact on the ocean, its impact on the land, we are not looking at just one data source. We are looking at multiple data sources. We are looking at data that has been collected from physical observation sites in the ocean, from float equipments which have been released into the sea, data that comes in through that. We collect data through satellites. There are several satellites that are there, geostationary satellites and satellites that orbit the Earth, which continuously transmit data into the Earth regarding all several of the properties that we are studying. So that is another data source. Beyond all this, we model data also using several modeling equations. We model future data as well as historic data. So you have a lot of sources of data that you depend upon, and it is based on these multiple sources of data that you then say that the climate of the planet is changing. So you have to appreciate the amount of work, the amount of what is it called? You calibrate this, you again validate the data, you again and again and again conduct an experiment. So one of the lessons that you study in basic science class is that whatever experiment that you do has to be replicated, has to be validated. So this data on climate change that you are looking at now has been validated several thousand times. And after that, you get a graph in which there is complete agreement between various data sets on the direction of change. So then you can say with complete certainty, at least to 90% certainty, that there is an increase in the temperature of the earth, which is most brought on by the intervention of the humans on the planetary processes. So that is the take home from this graph, that ocean temperatures are increasing. Ocean temperatures are not increasing uniformly. In the upper 700 meters, there is an more rigorous increase. Below you have increase, but not to that extent. This increase, above 0 to 700, there is a major increase. Below that, there is a lesser increase, because of which there is a process called stratification that is happening in the ocean waters. Scientists say that our oceans are becoming more stable. Now, that is not something that you should find joy in, because always we find, there are certain terms that we find to denote positive aspects. We somehow, think that a stable thing is a good thing. But when it comes to oceans, a stable ocean water is not a good thing, because what does it prevent? A stable ocean water prevents the mixing of nutrients between the various layers of the ocean waters. So because of which there is no mixing of nutrients that happens between the lower, cooler, nutrient-rich waters with that of the upper, hotter waters. So the upper ocean waters therefore become more and more nutrient poor. This is a result of increased stabilization and stratification of the ocean, which again is a result of increased warming of the ocean waters. So that is just for your, just for you to know. But let's move on to what changed due after. And let's say this is the point of departure, 1990s. You can see that till then our oceans have been much cooler. What does an anomaly mean? Now, again, this is just for you to grasp the concept. Don't be, overwhelmed by the numbers or the figures and the number of years, the baseline years. Just don't be overwhelmed by all these things. Let's try to understand the concept of anomaly. Anomaly is a difference. Now, that is how you try to make sense of the changes that are happening to the land atmosphere as well as the oceans. Now, very simply put, how do you know something has increased or gone up or gone down? That is by comparing it with a baseline figure. We say that compared to say 1950, the temperature has increased, right? So then our assessment would be, between 2020 and 1990, what is the increase that has happened, right? So that difference is then known as the anomaly. So when you look at the anomaly, that is the difference in temperatures from a baseline year normally is taken not just as 1 year, it is taken as a period, say between 1850 and 1900. Just so that we'll get a century of change, we take it between 1850 and 1990, and then take the average of the temperatures that existed between 1850 and 1900. You get a figure, and then that figure is compared with the temperatures of the succeeding years. That is how we arrive at an anomaly, and this is an anomaly plot. What is the change? And you'll see that after the 1990s, the temperature, the anomaly is positive. That is, there is an increase, a huge increase in the global ocean heat content. So whatever, extra heat that has been generated in the atmosphere due to an increase in the carbon dioxide gas concentrations has been taken up at an increased speed by the oceans. And as a result, this is the trend in ocean heat content. Now, geographically, let us try to place this. How does it look like? Now, here, because our region of interest is always what happens around India, you can see that there is an increase in ocean, because from 0 to 6, this is the red part. And here you can see that this area is totally red, which means there has been an increase in heat content in our Indian Ocean also. And like I said before, the increase in the full depth ocean heat content is 0.55 to 0.79. This is an old figure. Just yesterday, it got revised to 0.88. So there is an increase, is again even more. And you then have to multiply this with the entire ocean extent for you to get an idea of the extent of heat that you are speaking of. So heat absorbed by the ocean is moved from one place to another, like I told you, through ocean currents, and it enters the rest of the Earth system by melting ice shelves, evaporating water, or directly reheating the atmosphere. Right. So now let's think ahead. What does it mean then that the ocean waters are warming? I told you about stratification and the stability of the oceans increasing. That is just one effect of increasing temperatures in the ocean waters. So you have the ocean waters warming up. What is the first thing that comes to your mind when you're thinking of warming waters? The first thing that should come to mind is that with warming waters, what happens would be the same thing that happens when you take your ice tray out of your freezer. The ice starts melting, and the speed at which ice melts is actually exponential. When you pull the ice tray out of the freezer, keep it outside, at first nothing happens, the change is very little. But when that ice melts and there is warm water beneath the ice, the rate of melt then starts to increase. So with warming ocean waters, the polar ice sheets and the ice shelves and the glaciers starts to melt. Now that is one very important impact of a warming ocean. Your ice sheet starts to melt. What happens with melting ice sheets? The sea level starts to slowly climb up. Now, in the current IPCC report, there is a very disturbing rate of sea level rise given, which just to show you the stark difference that has come to play. Between up to 1971, the rate of sea level increase was just 1.3 millimeters per year. So every year, 1.3 millimeters of increase in sea level up to 1971. From 1971 to 2006, this increased to 1.9 millimeters per year. So every year, the increase was to 1.9, which is around 2 millimeters per year, you get an increase. But after 2006 till 2020, the rate of increase is now 3.7 millimeters per year. So look at the difference that has come to mean in just 20 years of time. Climate change is so frightening. It's so dangerous because it is happening in very small periods of time. Now we all know of how the planet came to be, the big ball of fire that our planet was, the cooling that took place, the ice ages that we have been through, the extinctions that have happened to dinosaurs and several other species, dominant species that ruled the earth before the humans. So you must be thinking, we have passed through, fire and ice, and these are just 1 and, even less than 1 degree Celsius changes in temperature. What are you speaking of? What you should always bear in mind is the time scale. Now, when you're speaking of this big ball of fire that the earth was, the ice ages, the dinosaur extinctions, all these happened in geological time scales of millions of years. You're speaking of 200, 300, 400 millions of years. Whereas climate change, we are speaking of 100 years, 50 years, 20 years. Within 2040, our earth is supposed to be 1.5 degrees Celsius more warm. And the IPCC report says that this kind of, rapid increases in temperature of the earth and of the ocean waters is unheard of in millennia. You compare this process with what had happened in, before 200 million years or 300 million years before, there is no such parallel where this kind of increase has happened in such a small amount of time. So what you should be concentrating on is the time scale of these changes within your lifetime. What is your age now? 10, 12, 15? When it is 2040, you will be 25, 30, the prime of your life. At that point of time, the earth is going to be 1.5 degrees Celsius more warm, 2 degrees Celsius more warm. And then another important aspect is that this one aspect of this change, an example is just to trigger your imagination. The Arctic ice sheet, when we think of the Arctics, the polar regions, all we can think of is this white ice sheet, that is what comes to mind first. In the coming 20 years to the 2040, the near term period that the IPCC has put to you, within that year, there is going to be at least a year in which there is going to be no ice in September in the Arctic region. I am not exaggerating. Can you think of a polar region without ice? September is the time when there is minimal ice cover in the Arctics. So that is what you map in order to understand the change in the ice sheets that are happening in the poles. So if the present heating of the atmosphere continues, and if oceans continue to absorb heat from a warming atmosphere, then there are going to be years before 2040 in which in one of these Septembers, the Arctic is going to be free of ice. That is the kind of change that you're looking at. And yeah, so coming to the Indian Ocean heat content has increased more than what is happening to the other oceans. So just to perk up the situation more, we are living in the tropics near the equator, and that is where the most of the changes that are happening because of the climate change is going to be manifested. Yes, the polar region ice is going to melt, but those waters are going to make its presence felt in the coastal cities of the tropics. The changes that happen in the ocean because of melting waters of the ice sheet and the changes in the composition of the fish species that happen are going to affect the fishermen of the tropics more than in the subtropics and the temperate regions. And that is the reasons of which, again, it's another storyline. But this is an introductory class to the kind of horrors that are in store for you. Okay, so this is just an illustration of how Indian Ocean is more than 70% of the global ocean heat gain in the upper 700 meters is concentrated in the Indian Ocean, just to make you aware of the fact. And let's skip this. And let's look at the trend in sea surface temperatures. And yeah, this is the Indian Ocean region. You can see that there is more heat anomalies in the Indian Ocean region than in the other. This is the Pacific. Okay, I need more time with these graphs, so we'll just skip this. And this is the Indo-Pacific warm pool, which is a body of water which spans the western waters of the equatorial Pacific to the Indian Ocean, which is holding some of the warmest sea waters in the world. Now, again, when you speak of the expanse of the ocean waters, there are portions of ocean waters which are more warm than its surrounding waters, not just the currents, but other bodies of waters. These are, large extents of waters which are bigger than continents. Now, this is known as the Indo-Pacific warm pool. Now, research has come out which provides evidence to the fact that the size of this Indo-Pacific warm pool has almost doubled in size. So this is the illustration. Now, this was the Indo-Pacific warm pool during 1900-1980. This was the size, and during 2018, it has spread this much. And the temperatures, the core temperatures, has also increased. Now look at this map. This core temperature increase is actually slowly inching towards the Arabian Sea portion where we are. And this is actually leading to differences in the behavior of the Indian summer monsoon. Now, we have been speaking about increasing in temperatures, right? When it comes to global warming. Now, how does increasing temperatures affect other climate parameters? That is how the entire climate change comes into picture. The other is just global warming. temperatures increase. With increasing temperature, other climatic parameters also get affected, such as rainfall, such as snow melt, such as heat waves, such as drought. Now, these are other parameters that get affected, then leading to what we now call the climate change in its totality. So one such, cascading effect that has led to an impact on the rainfall that we get over India is the expansion of the Indo-Pacific warm pool. So to put the impacts of ocean warming into perspective, warming of ocean water raises global sea level because water expands when it warms. Combined with water from melting glaciers on land, the rising sea threatens natural ecosystem and human settlements in low-lying coastal areas and island nations. So what happens if sea level rises? Sea level rise is now around 24 centimeters. The sea is higher by 24 centimeters. But according to the most recent IPCC report, by 2100, it is set to increase at least by 1 meters if we carry on with this current level of emissions. The most dangerous pathway traces the sea level rise to be at least 1 meter above the current levels, which would sink most of the coastal cities that we know of, because the life on our continents are mostly concentrated in a region between 0 to 2 meters above mean sea level. Many of our coastal cities, many of our natural heritage museum centers, buildings, livelihoods are concentrated in this narrow strip of land which is abutting the oceans, because that is where trade abounded. That is where civilization developed, in the coastal reaches. And it is the coastal reaches which are the most prone to the impacts of a rising sea. Warming oceans are also implicated in the thinning of ice shelves and sea ice, like I explained to you, and which have further consequences for the Earth's climate system. Warming ocean waters threaten marine ecosystems, reduce marine primary productivity and human livelihood dependence on them. Warm water jeopardizes the health of corals, because the Great Australian Barrier Reef is actually under threat with increasing impacts of the ocean warming. I'll get to it now. Increase in the number of occurrences of severe cyclones and increase in their intensity, which we have for the past couple of years. We are, we have come to know cyclones easily by their names. It is a very recent phenomenon. You asked me what were the cyclones that were, that had affected me last year. I would say Tote and Yas. That is a kind of familiarity we have come to gain, which is an indicator of the increase in severity and frequency of these this extreme events. And this is impact on ocean warming leads to a decline in net primary productivity. This shows the increase in sea surface temperature. The orange is actually an increase, whereas the blue shows a decrease. So with increase in sea surface temperatures and the stability of the ocean, these two I explained it to you, there is a decrease in chlorophyll and nitrate, phosphate, and silicate contains, which means that there is a decline in the net primary productivity of oceans. So if the primary productivity of oceans decline, it would then translate to mean that your fish wealth is going to reduce in the coming years. And that is supposed to be the most prominent in the tropical waters. A study conducted in the recent past puts the decrease to be as high as 50%. That is, in the coming years, there is going to be a decline in the fish productivity up to 50%. And that is already on. I actually am running a project in which I'm speaking to fisher people on the reduction in the fish wealth, and there is tremendous decrease in the fish catch, fish distribution, the kind of fishes that are getting caught, and which is a direct impact of the changing waters in the oceans. Now, this is a decline in the phytoplankton growth. This violet area that you see over here shows a significant decline in the primary productivity of the oceans in the Indian Ocean region. Now this salinity, sea surface salinity is also increasing. Now the processes and the science behind it I'll leave for now, because again that is it'll take up a bit more time. I'll just give to you the major changes that you should be aware of. Acidification of the sea. Now, the ocean pH has dropped from 8.2 to 8.1 since the Industrial Revolution. That may look like, paltry change to you, very little. But you should remember that this is a logarithmic scale. pH is measured in a logarithmic scale, and therefore a fall from 8.2 to 8.1 means a change in 120% difference. And therefore, this kind of pH differences can mean difference between life and death for many marine species. Now, for you to relate to this more easily, let me tell you this. The human body is its physiological functions are set to function at a particular pH level. If there is even a 0.01 change in that pH level, most of our physiological processes will stop. Our kidneys, our heart, and our brain will stop functioning. So imagine an ocean in which the acidity has increased from 8.2 to 8.1, and it's supposed to increase to 7 to 7.9. I mean, increase in acidity and a decrease in pH, which are both the same. So which means the oceans are going to get more acidic. And here you'll see that the Indian Ocean rate of acidification is more than the global rate of acidification. Global rate, while it is 0.018, the Indian Ocean rate is 0.02. So the ocean waters are acidifying at a fast rate, and this is just an illustration of carbon dioxide getting dissolved in the ocean waters. Now, this carbon dioxide is not getting absorbed from the atmosphere. In addition to atmospheric carbon dioxide that is getting trapped by the ocean waters, there is also release of carbon dioxide into the ocean waters through vents in the ocean floor, volcanic vents. These also release some carbon dioxide, and this is just a contrast photo in which these light blue bubbles that you see over here are carbon dioxide bubbles. I was so enthralled by this photograph in which you can really see seawater mixing with the carbon dioxide that I put it up. But then this is also another source of carbon dioxide. This is a natural source, but most of the carbon dioxide that gets entrapped in the ocean is because of anthropogenic contributions. Now, this is another impact of warming ocean. There is increased oxygen minimum zones. That is, increasingly in the ocean, you have dead zones coming up where there is absolutely no oxygen and therefore absolutely no life possible. And you look at this graph, this map, you can see that one of the regions is the Indian Ocean. So you are living near to a dying sea, to put it dramatically. And there is an increase in ocean heat waves that are happening. And ocean heat wave is a very recent phenomena. And this map shows you the distribution of the marine heat waves that have been happening after 2000. It is a concentrated area of high temperature of ocean waters, and this results to complete desertification of that particular patch of water. Due to an increase in such a rapid increase in ocean temperatures, what happens is that whatever life existed in that particular patch of water, that will migrate off to cooler waters. Therefore, for that period of time, which can last up to 3 to 4 years, a marine heat wave, that patch of ocean will get desertified. There will be absolutely no life. One thing. That. Second is that it will start influencing the climatic processes which are close to the continent in which it is situated. So if you have a marine heat wave, along with it, you have other land processes such as increasing temperatures, heat domes getting built up, wildfires that happen as a result of an increase in temperature. So it is a cascading, level of impacts. It is not just one level of impact that you need to expect with climate change. And increase in the number of cyclones. Now, this is just to illustrate to you. Look at the Arabian Sea. Off the west coast, we are supposed to be, safeguarded from cyclonic activity. In 1990, there was just one cyclone which happened in the Arabian Sea. And what happens in 2019? Just take a look. Now, these are paths that the cyclone took from its genesis in the ocean to landfall. And with the change in the color is actually a code for the increase in the wind speed. It's built into a depression, building into a cyclone before it falls into the land. Some of it does not make landfall, it will dissipate in the ocean itself. But these lead to changes in the atmospheric circulations, in the wind patterns, which then affect the climatic processes in the land. In 2019, 5 out of 8 cyclones that impacted India was formed in the Arabian Sea. So to give you an idea that people who live on the west coast are no longer safe from cyclonic activity. This has deep meaning for fisher people who fish in the seas, because with increasing cyclonic activity, the number of days in which they can go out to fish in the sea then reduces. That is also another impact, along with reduction in the sea, the fish catch, fish distribution, fish species. Along with that, you have cyclones and other extreme events happening, which will also reduce the number of days in which they can go out to fish. So that is another impact. Here we are looking at and the global mean sea level rise. I won't go into it in detail now. Just to give you this another point that I stressed upon, that there are various sources of data that you bring together to study a particular phenomenon. Here, when you study global sea level rise, there is tide gauge data. There is gauges that are situated in several dams, because release of waters from the dams also ultimately affect the amount of water that is released into the sea. Satellite data. And it is together with all these data that you then build your case up. So here, after 90s, satellite data became available, and it is very clear that whatever physical data that you had collected using tidal gauges kind of aligns with the data that was given to you by satellites. So it is just another confirmation that whatever proof, that evidences that you are collecting on the changing climate, on the warming seas, is actually going in the right direction. Now, this is the Antarctic mass variation since 2002. You can see the steep decline in the mass of ice sheet in Antarctica. The rate of change is 151 billion metric tons per year. And this is the Greenland ice mass, which is again decreasing at a faster rate. And so rising sea levels, we can expect the ocean to rise between 26 to 77 meters, says the assessment report of 2000, assessment report 5. But the newest assessment report says it can go up to well beyond 1 meters if we continue the present rate of emission. Submergence and flooding of coastal lands, saltwater intrusion into surface water and groundwater, great contaminations of your, you cannot escape from these impacts saying that, okay, it is the ocean water rising, or how does it impact us? It is going to impact your surface water and groundwater sources. It is going to lead to saline water increases, which can be kilometers into inland water sources. It can pollute your groundwater levels, increased erosion, and it has got social and economic repercussions. Roads, railways, and other farmlands, your infrastructure, these are going to be affected. And several of the island nations of Kiribati, Tuvalu, Marshall Islands, Maldives, these are island nations in the Pacific that are preparing for mass exodus. It is these look like stories to us, that a nation which we knew to be an island country till very recently is going to be another long landlocked country in some other country. Maldives is actually planning to buy land in other continents, because they are very sure that within 100 years their island is not going to be there anymore with increasing sea levels. Not just Maldives, several such island nations are preparing to abandon land. In part, again, Indonesia is planning to shift its capital from Jakarta to another higher land. Several such nations are contemplating such changes. This photograph that you see over here is Venice. Venice used to be famed for its water courses, how its highways are all waterways. And it was supposed to be a paradise, whereas these days, with increasing extreme events, 80-90% of the land is getting submerged during the rainy seasons. So this was just 2012 when people first became aware of the fact that the world that they know is going to change forever. So this is like I told you before, there is going to be a change in the fish patterns, and it is leading to already there are international disputes and wars over migrating fish. Now, fish, when it migrates in search of cooler waters, do not look at borders and nation boundaries. So there has been a lot of conflicts that have been going on between nations on border crossing fish. um, Again, something for next class. So this shows you the difference in the fish distribution. Again, I won't get into it now. Yeah, so if there are more details that you wish to hear on any of these, I can take that in the questions session, so that I can give you time to raise questions. Thank you for your attention till now. Thank you.
Thank you, Sarita Madam, for your wonderful presentation. And the floor is open for discussion and questions. Students, you can ask question or write it in the chat box.
Yeah. So as I explained to you, the ocean actually heats up at a lower rate than that of land. Land heats up the atmosphere. Whatever heat is getting built in the atmosphere is getting absorbed by the ocean waters. But that absorption, because we know water does not get heated up faster than the land, the absorption rate is less. That is why when you look at the figures now, IPCC assessment report 6 says that till 2020 there has been a built-up of heat of 1.09 degrees Celsius. You divide that, you will see that the heating up of the land is actually 1.59 degrees Celsius during the period, whereas ocean has heated up to a degree of 0.88 degrees Celsius only during this period of time. So the increase in ocean waters is actually the buildup of heat in the ocean waters. Let me show you that graph. I'll do one thing. I'll share the presentation also with you. So the increase in ocean waters, the heat of the ocean waters is actually less when compared to the land. But what is more important is that even with that lesser increase in the warming of the ocean waters, the processes that it influences are much more than what is there in the land. So it is triggering a lot of physiochemical processes within the ocean, which then impacts the land in turn. So another thing that you have to be aware of that is that the time scale of events in an ocean is different from that of the land. So when an ocean takes up heat, it is not to keep it to itself. Like I showed you, it will transport it through the circulation channels to everywhere on the earth. That is how it is affecting the other climate parameters. But along with it, this particular heat that has been absorbed by the ocean will one day or the other be released back into the atmosphere. So therefore, it is a kind of delayed holding of the heat. Therefore, that is why it is said that climate change, even if you put a break to climate change now, the impacts that have already happened to the atmospheric processes is not going to stop. It is mainly because of the role of the ocean. This 0.88 degrees Celsius increase in the ocean heat is going to be transmitted back into the atmosphere when the ocean cannot hold on to any more heat. So that release back into the atmosphere is that cannot be that cannot be unstopped. It will happen. in a time scale which is very different from the processes in which land happens. I hope that is clear.
Second question is here.
Second question, just a second.
Sir, I have doubt. Is it dumping of plastic in ocean increase the temperature?
Yes, it is. I'm glad that this point was brought up, because and climate change, how much so ever you talk about it, the reason why we are not able to appreciate climate change, because it is global. The impacts of it is happening onto certain intangible variables like temperature, rainfall getting affected here would be due to processes which are happening elsewhere. So it is not easy to grasp the scale of changes that are happening at a global level. But even before climate change led to such large impacts in the ocean waters, what has been affecting the ocean to even to an extent even more and to dangerous levels have been the threat of pollution. So that is a local process of human intervention that has been happening in our seas. Now, what is global climate change? Global climate change is because of the actions of the humans on the atmosphere. So you have, for example, let's take this petroleum industry, of which you have a plastic producing company. The plastic producing company emits emissions into the atmosphere that then gets leads to an increase in carbon dioxide buildup in the atmosphere, which leads to increase in atmospheric temperature, which gets absorbed by the oceans. Because it gets absorbed by the oceans, there is increase in acidification. An increase in acidification then leads to depletion of the marine species, right? That is one path, which is a global cycle. Let's look at the other side of it. You have this plastic producing company, it produces plastics. Emission is only a byproduct, right? It produces plastics. These plastics are consumed by the people. And because plastic consumption is such a frivolous activity, we tend to use and throw plastics. And once these thrown plastics make its way into the water bodies, because this is one basic human instinct. You have a kali plastic bottle, the minute you start crossing a railway bridge on top of a river, you tend to throw that plastic into the water. There is some kind of affinity, you have some kind of plastic waste in your hand, you see a water body, you feel that it belongs there. These are certain instincts that you have to really rein in, but just to show you how these then end up in the ocean. This is a more direct route. You have a plastic company, it produces plastics, you use and throw plastic into the water, it makes its way into the sea. And there are these islands of plastic that then gets built up in the ocean. And these slowly leach nanochemicals into the water, and that then affects the phytoplankton growth and the marine fish species. Both impacts are actually significantly affecting the marine species. It's not like climate change is a bigger threat than the direct pollution due to plastics. But what I want you to understand are the two different pathways through which our oceans are getting affected. The thing is that you put a stop to the plastic production as such, both these pathways get disrupted. So that's a good news.
Thank you, Madam. The Reverend Sargunam, the Eco Director of Coimbatore Diocese, will propose vote of thanks. Sargunam, please. Switch off the mic. Yes, please.
Right. Good evening to all. Greetings to you in your Lord Jesus, name of our Lord and Savior Jesus, Lord and Savior Jesus Christ. In our church, CSI logo contains saying that they all may be one. This was understood as it is mentioned only for human, but our ecology department to us it's global. Really, I thank to our Synod Director, Dr. Matthew Koshik. I have attended many sessions with his leadership. Now I praise God. It is a great honor and the privilege to propose a vote of thanks on this wonderful occasion. First of all, I start by giving glory to Almighty God for the making today's occasion a resounding success. First first and foremost, I thank our special guest, Mr. Dinesh, the coordinator, Ecumenical Water Network, WCC, Geneva, who, despite this busy schedule, has found time for the grace this occasion. And also, I express my heartfelt thanks to uh, Ms. Sreja, KG scientist, climate impact assessment for the valuable contribution. It's very eye-opening session, giving many data about the ocean. First of all, she started only one ocean. It was very enthusiastic to listen his whole session. I thank and each and everyone invites the person here for the accepting our department's invitation. I thank each and everyone in the ecology department for your cooperation in making this event a resounding success. Thank you very much.
Sargunachan, you kindly pray and close the meeting.
Okay. God of Almighty, thank you for this wonderful session, for those who are leading and continuing presence for the valuable contents. We have a more concern about our everyday living with the nature. You give the whole nature for the more wisdom and knowledge, but we have our selfish, we destroy the world. But you have given the new thought in your humanity for reconstruct and renew the creation for this wonderful world.
Amen. Thank you very much for attending this program.